All right, so welcome, guys. This is Professor Roldan with College Algebra, section 1.2. Now, this is about linear equations and rational equations. What we're going to be doing is solving, and we're also going to be solving equations with fractions, also with rational equations, and we're going to be able to recognize identities, conditional equations, and inconsistent equations. Okay, so let's get started. First of all, a linear equation in one variable is an equation that can be written in the form of ax plus b equals 0, where a and b are real numbers and a does not equal 0. So basically, what we're going to be talking about later when we talk about graphing is this kind of looks like y equals mx plus b, okay? And that is a linear equation in slope-intercept form. And so what we're going to be doing is solving more complex equations, but this is the basic idea. All right, so let's take a look at what are the steps to solving. Okay. Now, there are three basic steps for all linear equations, and that's to simplify. Number two, to collect variables to one side and get all the other numbers to the other side. And the third step is to just go ahead and isolate the variable. So those three basic steps. But when these equations get very large, we can end up making many steps to get to this point. So it sounds simple, but let's just kind of take a look at the formal steps here. So first, you're going to simplify each side of the equation. Okay, you can do that various ways. Things like clearing the parentheses or grouping symbols. Usually they're parentheses. Okay, and you can do that by distributing. You can do things like combine like terms on each side. You can also clear fractions and decimals, which we're going to do later. Okay. Let's go ahead and get that down. Okay, so after you simplify the sides, then you want to go ahead and get the x terms to one side and all the numbers to the other side, or the constants. So collect variable terms, collect variables to one side and all constant terms to the other side. Okay. Step one, step two, and then after you do that, it's going to look pretty simple, and you're probably going to do one more step to isolate. And basically, when you get x by itself, you have solved it, okay? Now, the last step is optional, but it's very useful, especially when the equations are complex and you want to know if you're on the right track. You can definitely check the proposed solution in the original equation, okay? Now, let's just kind of apply these over here. So 7x minus 14 equals 0. Now you could probably solve this by inspection. That means you just kind of say, well, what x would I need to multiply by 7 in order to subtract 14 and get 0? Well, I know 14 minus 14 is 0, so I need this x to be a 2. That's kind of our initial guess, but algebraically speaking, we want to go ahead and get, since the x is on the left, we want to go ahead and get the 14 to the right side. Okay, and that's going to give us 7x equals 14, and then you want to go ahead and divide by 2 and get 7. Now, I'm sorry, get 2. Hey. Sorry about that. Divide by 7 and get 2, a little ahead of myself. All right, so let's go ahead and check this. So you just take your proposed solution 2, put it inside, and we get 14 minus 14, and that equals 0. Okay? So our solution is going to be in set notations. So the solution set, which is just a 2, is going to be in these braces here. Okay, wasn't very good, but it's kind of weird doing this with this pen. Okay, all right. Let's go to the next one. Pretty sure you can handle that one on your own. So go ahead and pause the video and do number 2. Okay, so for this one, I'm just going to skip the algebraic steps and go and just say them. So we're going to subtract 3 from both sides. So that's going to be 2x equals 14, and then divide both sides by 2, and we get 7. And if you check, plug in your solution to see if it equals 17. So that's 14 plus 3, and 17 equals 17. Okay, so the solution then is going to be 7. Okay. All right. Now, let's basically apply all the steps that we talked about in the right side in blue for number 3 here. Okay, so step number 1 is to simplify. You always want to get your equations simpler, as simple as possible, and keep working at it until you have some basic equations. Okay, so first thing, I see parentheses on the left, I see parentheses on the right. We're going to distribute and clear those out. So that's going to give me 2x minus 6. And this 16 should be a 17, by the way. So let's just put this, make it a 17. Okay, so we distribute, on the right side we're going to distribute negative 3. So negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. So then we look for like, so we did that. Now we need to find like terms. So we see some like terms here on this side, and we see some like terms right there. So we're going to go ahead and simplify that. Okay, and now step Step 2 is to collect variables to one side. So we got this thing simplified as much as possible. But we want to get the x terms to one side and the other terms, or the constant terms, to the other side. So I'm going to you can pick whatever side you want, but it's recommended that you choose the smallest variable. In other words, smallest coefficient. In this case, this -3 right there, because we want to keep our variables positive. So you'll see why in a minute. So if I go ahead and add 3x to both sides, see, now on my left side I have a positive 5. Okay. Then we go ahead and add 23 to both sides. Whoops. And that's going to give us 30. Right? And then you divide, let's just go ahead and show that for now. And then, divide by 5. So our proposed solution is 6, okay? So what we want to do is go ahead and check this on the right side, because this is a long equation, it's big, and so we want to go ahead and make sure we didn't make any mistakes before we move on. So we're going to check this thing. Alright, so plug in the 6 where the x's are. Okay, and now we just do the calculations one side at a time. So we can do 6 minus 3 is 3, and then that's 6 minus 17, and then 6 minus 17 is negative 11. We go to the right side, see what that equals. 13, 6 plus 2 is 8. 3 times 8 is 24. 13 minus 24 is negative 11. So we just checked and verified that this proposed solution is in fact the solution set. Okay. All right. So go ahead and try number 4. And this time, we're going to use a different way to check this. So go ahead and pause the video and try number 4. Okay, so you should be done with number 4 on your own. So here I have the work shown. I cleared the parentheses on both sides. I combined like terms on the second step. I added the x to both sides. So I moved it to the right side, made 8x, 9x, moved the 6 to the left by subtracting it, and getting 12 minus 6 is 6. Divide both sides by 9 and get a fraction 6/9, which reduces to 2/3. Okay. Now, how do we know if this is right? Well, as you can see, it might take a while with all the fractions and everything to actually check this numerically, using, plugging it into the original equation. So on page 109, sorry about that. On page 109, check using technology. Okay, check using technology. Now, those of you who have graphing calculators at home or whatnot, you can use to check this. Like I said in class, you are more than welcome to use technology to aid your learning, so you can see the visuals and check your answers and stuff like that, give you more confidence. But of course, these things are not allowed on these tests. So remember to, just a word of caution, not to be reliant on technology only just use it as an aid for learning and checking your answers. So on the test, make sure you know how to do these without technology. All right, so that's just my little disclaimer. And we're gonna go ahead and it says you can use numeric and graphic connections. The numeric takes a little bit while, but basically the concept is that each side of this original equation, each side, we're gonna treat it as an equation, a separate equation. So basically, we're gonna type in the left side into y1 on your graphing calculator or on a site called Desmos, okay? Now you can go to desmos.com or you can download the app for Desmos like I mentioned in class. Okay, the app is obviously much quicker, you have easy access to it. Or if you're for some reason can't download apps or you run out of space, you can just type in desmos.com on your personal device and that will get you to this, just a second. So that's going to take you to, let's see here, I saved a screenshot of it. This is the website. Okay, desmos.com. All right, here we go. I got this figured out now. So here's the website, which you can go on your computer or phone or tablet or whatever, desmos.com. And they have a lot of cool stuff on there. But basically, you want to just go ahead and start graphing, okay? And so when you click on Start Graphing, you're going to get, on the left side, you'll have your areas where you will type in your graphs. And you can do the same thing on a graphing calculator. Now, mind you, a graphing calculator, the technology is more than 20 years old. Even though it might look cool and it has color, but really to find some of the answers we're going to be looking for on this graph, it's going to take a lot of steps. So using something like this will instantly give you the answer. So I'll show you in a minute. Okay. So you want to type in the left side of the equation. It doesn't matter what equation that you have, like I mentioned in class, you put the left expression as y1 and you put the right expression as y2 for the second equation, and it's going to graph two lines with different colors, and the answer is going to be, or the solution is going to be wherever they intersect, the x-coordinate of the intersection. Okay, it's gonna, so after you type in with the menu down there, you're going to be typing in the equations, the equation for number 4, or the equations for number 4, left and right side, and you're going to get something like this. Okay, so remember the left side is -3 times the quantity x minus 4 plus 2x. The right side of the equation, the original equation, is 4 times the quantity 2x plus 3 minus 6. So make sure you put parentheses around those. And as you can see, one is red, one is blue. And the intersection, whoops, the intersection is 0.67, where they rounded that. So that's basically 6 repeating, and 6 repeating, that is 2/3, okay? That is 2/3. So our answer let's see here, just a second. Okay, I can't move that. So our answer is going to be 2/3, exactly what we just found right here. Okay, because the decimal format of that is 6 repeating. Okay, so that's how you can check any of your work that you want to. Okay, and as we get into fractions, we'll see fraction equation. You'll see how useful this is. Okay. All right, let's go to number 5. Okay, so let's take a look at number 5 here. We have another long equation, multi-step equation. So we have, hey, let's clear these parentheses, let's combine like terms, stuff like that. All right, so 2x plus 6 minus 4, 2x plus 3, and then those two. So what we have, all right, so let's stop right here and take a look at something, because before we go on, the rest of these equations on this page, most of them, not all of them, some of them are going to look weird as far as you keep working through it. Maybe the x's will cancel out completely, leaving you with just some numbers on the left, numbers on the right, and it looks kind of confusing. So I just want to stop right here, because you can tell these two x's, the 2x on the left, 2x on the right, they're going to cancel each other out. Okay, so before I show how weird that looks, I just want to point out that back at the beginning we talked about how y equals mx plus b is the typical linear equation, okay, or ax plus b. M is the slope. So if we look at these two and we treat them as two separate equations mentally, we're saying, hey, this is y1, y2, and you put this in your graphing calculator or on Desmos, you'll see that these two have the same slope. Same slopes, these two. And they also have different intercepts, okay, right there. They have different intercepts. I know we haven't got to this yet. But this is just some review from Algebra 1. Y equals mx plus b. They have the same slope, different intercepts. Basically, if you go ahead and put this on Desmos if you want, you're going to see that they're going to look like two parallel lines, okay? And you can use Desmos to verify. So in the previous example, we used Desmos to look at the intersection, and that intersection was the solution. The x-coordinate was the solution. But when you graph these two, they are parallel. So what do? Well, these never intersect. There's no intersection. And if there's no intersection, that means there's no solution. Okay? And so that is where this is going to go. So if we go ahead and subtract 2x from both sides, then they're both going to cancel out, leaving you just with the 2 on the left and a 3 on the right. Now, I don't know about you, but 2 equals 3 doesn't make any sense. That is a false statement. Okay? That is false. And if something is false, in algebra, we're going to say that there is no solution. So, no solution, or you can do the null set. In terms of sets, we can do the empty set as well. So, previously, you get an answer, you put that answer into the braces. If there is no answer or no solution, then the braces are empty, and that we call the empty set. Okay? So this brings us to our next topic, and that is many times there's types of equations that we can see, or that we'll be dealing with. Okay. And the first example that we've been doing, if we get an answer, is called one solution. Or one scenario is when you get one solution. And remember, we used Desmos, and we saw that there's going to be an intersection of those two equations, okay, y1 and y2. Okay, so that's one point of intersection, and that point of intersection is going to be called. That's going to bring us to the type of equation called conditional. Let me use red here. So conditional equation. All right, where the solution will be some number x that you solve for. So, if you get 5, -5, whatever, that number goes in there. That is the x-coordinate of that intersection, okay? It's the x-coordinate of the intersection. So that's what we've been doing so far, but the one we just did, number 5, there is no solution. So that is another type of equation. And that's called, that's where you get no solution. And like I said before, that's because if you look at the lines for each of the expressions on the left and on the right, they don't touch. Okay? Why? Because these are parallel. That's the definition of parallel. Have the same slope or the same angle, never touch anywhere. So there's no point of intersection. And if there's no point of intersection, guys, and that means that this is called an inconsistent equation. And like I said before, this can be the empty set or the null set. It doesn't really matter. It's a circle with a line through it. Okay. All right. Now, what we're about to encounter in number 6 is the third type of equation. And that is infinitely many solutions. Okay? This is when you do visually, you put y1 in there, and then you put y2, and it's the same exact line. So where do they cross? Where are the intersections? Everywhere. Everywhere you look, there's an intersection. Okay? Every single spot on there, there's an infinite amount of intersections. So we'll call that we'll just say many points of intersection. Okay? These lines basically coincide. Okay, they're the same basic line. This is where y equals, they equal each other. Okay, it's the same exact thing. All right, this is going to produce the concept of the identity. Okay, and the way this is expressed is all real numbers. This is in set builder notation, so it's the set of all x such that x is a real number. Okay, that pound sign is just I ran out of room there, so it's just abbreviation, or not abbreviation, but it's a symbol for number. Okay, x is a real number. So if you see that in the textbook or in the My Math Lab, that's what we're talking about. Okay, it's infinitely many solutions, or what we call an identity. Now, so let's take a number 6 and see what happens here. So go ahead and do number 6 on your own and see what you come up with. So pause the video and press play later. Okay, I stand corrected. This number 6 is one solution, which is x equals 5. So that would be basically a conditional equation, just in case it asks you for that. Okay, that's just a normal scenario. So it's actually the one I was talking about was number 7. Let's see what you get for number 7. So go ahead and pause and see what you get. All right, we're back, and here's the work for number 7. And basically, on the second step right here, you could tell that these, if you looked at it, for the left side is a line and the right side is a line, y1 and y2. They're exactly the same line. So if you graph them on Desmos, you would get the same line. You wouldn't see two lines, okay? So this right here tells you that they are identical equations, or that they coincide. And that just brings you to, you can basically from there stop and say, well, this is a identity, okay? Identical equations are an identity. Or if you finish it off, you can see it right here as well, okay? So you would do your answer like this, okay? All right, let's move on to the next few and see how you do. So go ahead and work on number 8 and number 9, and then I'll show you the answers after you pause the video. All right, we're back. Here's number 8 and 9. See how you did. So number 8 was simplified and solved and reduced at the end to get -5/4. Okay, we can check that if you want using Desmos, or we can do it the long way. It's not that bad, actually. It's negative. So the 4's cancel out, leaving you with -5 plus 3. That's -2, which is 6. Over here, the 4's cancel out over here. 11. Oops, that's a +6. Okay, so there is number 8 checked, or you can use Desmos to help you out with that as well. Okay, number 9, we quickly saw 4x equals -12 is the same on the left and on the right, so that's an identity. Those are identical lines, or coinciding lines, so the answer is all real numbers written in the form of the set of all x such that x is a real number. All right, let's go ahead and go on to fractions. All right, here we have linear equations with fractions. It says eliminate the denominator by multiplying both sides by the least common denominator, which is the smallest number divisible by every denominator. Okay, so the LCM, so this is the least common denominator, or I like to call it the least common multiple. Okay, so the least common multiple of 4 and 3. So let me go ahead and rewrite this so you guys can see it a little bit better and have more room. So the strategy is to multiply both sides by the LCM. In this case, what is the LCM? Well, the LCM between 4 and 3 is 12. Now, how did I get 12? Well, here's the long way. Here's the breakdown. So multiples of 4 and 3. So 4, 8, 12, 16, and it goes on forever. 3, 6, 9, 12, 15, it goes on forever. So the least common that they have a lot of numbers and a lot of multiples in common, but the least is just the first one that you come to, which is 12. Really, you just think of both 4 and 3 divide into 12. Okay, so we're going to use 12, and we're going to multiply both sides by 12. Okay, now it actually works out. To me, it's better to have this broken up into pieces. So you want to multiply every single term. There's 3 terms here times 12. So the x plus the 2 over 4 is multiply that by 12. The second term by 12. Oops. And well, we can already see 12 times 2 is 24, so we can just multiply that. So I think it's easier to see instead of distributing in your mind. Just go ahead and write the 12s on every single term. So now what's going to happen is you're actually going to the strategy of LCM, or multiplying both sides by the LCM, the strategy is basically helping us with this idea of clearing out the fractions. Okay, we want to clear the fractions. Okay, that's I mentioned this before. We're clearing the fractions. How do you do that? You multiply both sides by the LCM. All right. And how do the denominators get cleared? Because we're doing division here. 12 divided by 4 and 12 divided by 3. So 12 divided by 4 is 3. And now we just have the numerator left. And then 12 divided by 3 is 4. And now we just have the numerator left. And we already did the right side. So now we want to go ahead and distribute, treat this like a normal equation after this. So 3x plus 6, 4x plus 4, 24. 6 plus 4 is 10. 3 minus 4 is -1. And then we're going to get this scenario. And then divide both sides by -1. Or just do that in your head. And we get -14. Okay. Now this is a pretty difficult equation, because of the fractions, a lot of steps. So we want to go ahead and check this, okay? Again, you're welcome to use technology. I'm going to do it the old-fashioned way. So I'm going to plug in the negative 14. See if that equals 2. So we get negative 12. And we get negative 15. So then we get this double negative. And so now we have negative 3 plus 5. Whoops. And then that's positive 2. And voila. There it is. Okay. Okay, so for number 11, I'm going to go ahead and get you started. We want to multiply by the LCM. So the LCM between 2 and 3 would be 6. Okay? So you're going to do this to both sides. So go ahead and stop the video and press play when you're ready to see how you did. Okay, so the answer that I got was x equals 26 over 5, which cannot be reduced. Okay. And now go ahead and stop the video and try out number 12 by yourself and see what you got. All right, here's the answer to number 12, 20. X equals 20. Okay. All right. Let's get to the last portion of this unit, 1.2, which is putting some x's in the denominator. That's going to create what's called rational functions, okay, or rational equations. So rational equations looks like this. All right, so same procedure. We want to multiply by the LCM, but this case, the LCM is going to equal not just 10 this time, it's going to be 10x. Okay, so remember, the goal is for the denominator to clear. So if we multiply by an x, that's going to make the x's clear. Okay, so this is perfectly fine, even though it looks awkward. All right, so let's go ahead and do multiply both sides by 10x. And distribute this. So basically 10x here, 10x here, and 10x here. So again, the purpose of doing this is that it clears out the denominators. Okay, you're going to create this division. So 10x divided by x, that means the x's cancel out. So that gives us 10 times 2 here. And right here, the x's do not cancel out, but you have 10 divided by 5 is 2 times the 1. And then 10x divided by 2x is 5. The x's cancel out, leaving you with 3. So now we'll just go ahead and clear this up, or clean this up. So 10 times 2 is 20, 2x times 1 is 2x, 5 times 3 is 15. So we turned this rational equation into this nice linear equation. Okay, so this is going to be 2x equals 5, and then divide by 2, and we're going to get x equals 5 over 2. Okay? X equals 5 over 2. Now, because these, you're not sure if you did the LCM right, just make sure that the x's cancel out. Okay? And sometimes you do have an x left over, all right, like right there. And that's okay. That's actually the one you're going to be solving for. So you don't want all the x's to cancel out because then you won't have an x. So usually you'll see a nice x somewhere. Now, put this in your calculator. It's a little bit more involved. I will, I'm sorry, on the Desmos app, it's even on the graphing calculator like the TI-84, it's a little tricky, so I'll show you how to check this using technology in class, okay? So what I want you guys to do is to try numbers 14 and 15, because when we get to class on Tuesday, we're going to go ahead and check this in our groups, okay? So we're going to start the class, see if you've been watching the videos and taking notes. Using 14 and 15, we're going to do both of those together in groups, and then that way you guys can help each other and see what you get, and then we'll go from there. All right, well, this is the end of 1.2, and I'll see you in the next video.